Okay, good afternoon, students. Today, let us study about the assignment technique or assignment type of problem. Maybe in my previous class, I might have hinted about this assignment type of problem because when I was concluding the session on the transportation technique, at the end I had mentioned about this one. So, because the assignment type of problem is completely degenerated form of transportation type of problem. So, let us see what is meant by assignment type of problem. Assignment in the sense there has to be, it has to be one-to-one. For example, let us say that there are 4 jobs and 4 people. This is always true. There are 4 jobs and there are 4 people. That means jobs, let us say that J1, J2, J3, J4 and people A1, A2, A3, A4. Okay? Now the another thing is here each job is to be assigned to only one person or each person has to be assigned only one job. That means no 2 people will be getting, they can be assigned to 2 jobs or one person cannot be assigned to 2 jobs like that. It is 1-to-1. Of course, it is basically used in case of allocation type of problem and widely in scheduling. For example, that is what I told you, maybe people, person and the job or machine and the job or maybe the salesperson to a particular territory or maybe the driver to the particular route like that. Maybe which route is to be assigned to the, for example, the railways and other things, railways or the aircraft. Which route and other things are to be assigned to because it gets wide applications maybe in case of the air industry wherein a lot of saving can be done. Okay, it has got basically, it is 1-to-1 and here availability is 1. There is only one person, that means here the availability is 1, A1 only can be assigned. Either he can be assigned to job 1 or job 2 or job 3 or job 4, but not simultaneously all, no. Here also availability of person is 1 and job, only one job, 1 like that. That means necessarily it has to have number of jobs should be equal to number of people or number of facilities. For example, here what are these things? These are the facilities. The number of facilities should be equal to number of jobs. The number of jobs should be equal to number of facilities. That is what it means. But the crust and each one has got only one availability. In case of transportation, we have seen that it was not one. It may be one or more than one. That means this one we had considered in case of transportation, the demand used to be one greater than or equal to 1 for each of the routes. And the supply is assumed to be greater than or equal to 1 for each of the rows, and in case of the demand is assumed to be greater than or equal to 1. But in case of the assignment, it is exactly equal to 1. And in transportation, it was not necessary that it needs to be the square matrix. Only thing was balancing is to be done. Here also the balancing is done since the availability and requirement for each of the source and the destination is 1. So necessarily it has to be a square matrix. That is what it means. That means this is 1 plus 1 plus 1 plus 1, it is 4. This is 1 plus 1 plus 1 plus 1 is equal to 3. Now you might ask me the question, suppose the number of people available are 4, but the number of jobs are 3. What is to be done then? That is a valid question. In that case, that is what we applied the principle or the method in case of transportation, same is to be done. That means the balancing has to be done first in any case. That means now here the number of people are 4, the number of jobs are 3. That means we have to add one column. If it is other way around, if the number of people are 3 and the number of jobs are 4, then we need to add one fictitious person like that. That means how much amount we are going to put it, that difference, that is 1 only. That means it should have, if it is a square matrix, then there is no harm. If it is not square matrix, then it is not balanced. It needs to be balanced, then accordingly we need to add one dummy row and a dummy column. Is it understood? Okay. Now let me ask you a question. Suppose there are 4 people and 4 jobs, it is balanced. Okay, fine. Next one is, if a job, the person A1 is assigned to job 1, how much cost is, what is his effectiveness? That means it is basically, again, I'll tell you, it is a cost reduction technique, just like the transportation technique. And it doesn't mean that the maximization type cannot be handled. Of course, I am going to take a particular set of problem which involves the maximization type of problem. That also will just try to consider about it. But try to understand effectiveness. That means what is his efficiency? So that if he is more efficient, that means he is going to reduce the time. For example, executing that particular job, he will take less time. That is what it means. So in totality, we want to reduce, or he will take less time means less cost. So virtually that means if the effectiveness is given, which I am going to provide you some values, which we may call it as Cij or whatever it is. Let me take up these following values. (15, 13, 14, 17, 11, 12, 15, 13, 13, 12, 10, 11, 15, 17, 14, and 16. What are these things? It might be the amount, maybe expressed in rupees, or it might be time as well. Okay? Don't get confused. Okay? It is effectiveness, that is what it gives. Whoever is going to take, say for example, if I consider that to by assigning the job 1 to A1, okay, it costs 15 rupees. And J2 to A1, 13 rupees. J3 to A1, 14. J4 to A1, 17. Similarly for J1 to A2, A3, whatever it is. Or you can say that he is going to take so much time, 14 or 15 minutes or 15 hours, 13 hours, 14 hours, whatever you can think about. Because similarly you can say that some tender is to be selected, because the bidding they will offer, many people, and for different jobs. Okay, in that case, who has to be selected for different jobs? Because there are so many examples, basically in scheduling, or which product is to be which product is to be assigned to which factory, because if they differ in the cost of manufacturing or the time, whatever they are going to take up like that, under those circumstances. So it widely finds in the routing type of problem. Here, the aeroplane industry, it can scheduling, it can done, and in traveling type of problem, and allocation of buses like that. So allocations of the jobs and schedule. So this is the basic premise on which it has to be built. Then how it is to be solved then? Try to understand, only one job is to be assigned to each person, or each person has to be assigned to only one job. That means no two, this thing. No two people can be assigned to one job. That is what it is. If it is understood, then how it can be done, how many ways it can be done. If you look at it, how many ways it can be done? there are if there are n facilities or n jobs and effective matrix is given, then how many these things are there? There are going to be, how many ways are there? There are n factorial ways. So try to understand, always in assignment type of problem, it is a square matrix. Either we can take it as n or we can take it m. It is n by n or m by m matrix. So factorial n. That means here there are 4. This n is 4. That means 4 factorial. That means how many ways are there? 4 factorial ways. That means how much? 4 into 3 into 2 into 1. So that means there are 24 ways. In the sense what? First I will assign J1 to A1, J2 to A2, then J3 to A3, J4 to A4. This is 1. The next one I can change. A1 to J4 and J1 to A2. Like that I can go on changing. So likewise I am going to get around 24 ways just for this one. Instead of this one 4, if it were 6 or 10, you can just imagine 10 factorial. How much it works out to be? Factorial 10. You may not imagine. Okay, it runs into lakhs of millions. Okay, under these circumstances, this enumeration method, it is going to consume a lot of time. Then somebody suggested, why don't you solve it by transportation technique? Okay, perfectly correct. Because it is already balanced, because availability is there and the requirement is there. These are the cost or whatever it is, the effectiveness is there. Yes, it can be solved. It can be solved by transportation technique. Then what is going to be the problem? Okay. Now you can see that the number of assignments can be only 4. Number of allocations can be 4. It cannot be more than 4, or it is going to be order of the matrix. If there are n columns and n rows, at the most we can have only n allocations. So in this one precisely, we can have 4 allocations, whatever it is. It cannot be. If we solve by any of the methods of initial feasible solution method, we are going to get it here 4 allocations. It cannot be more than 4. That is what is going to happen. Okay. Then how many, because if it is to be tested for optimality, then how many assignments need to be done? That it is going to be n plus n minus 1. This is 2n minus 1. Or in this case, it is going to be 2 into 4 minus 1. This is going to be 7. There has to be 7 assignments, but I am going to get only 4 allocations. Hence, what is going to happen? The problem is, it will be a degenerated form. In fact, it is completely degenerated form. If it is completely degenerated form, then I have to allocate some epsilons. How many epsilons? N plus n minus 1. That means there has to be 7 allocations. Now I get only 4 allocations. That means 3 epsilons. That means epsilon 1, epsilon 2, epsilon 3. They need to be allocated into different cells so that they will not form the closed loop, and yet it is to be allocated to the least cells, cost cells. Try to understand. So which will make it more complex. And the people, they started thinking, that is one way is what? I told you, all the elimination techniques, which will become more lengthier. The next one is transportation technique. Okay, in that case, yes, this can be solved, but one faces this problem. Next way, that is what they thought. One Mr. Koning, he of Hungary, he developed one method and he named it after his country, and it is called as Hungarian method. Hungarian method. Okay. It was developed by Koning for this particular set type of problems. It is also called as floods technique. So all means the same. Coning technique, Hungarian method or Flood's technique means all means the same. Don't bother much about it. And this method is based on two theorems, two premises. Okay, let us see what are those premises before actually going for the method itself. Before I explain the method, I want to just mention about the two theorems. What? Because the two theorems or the two premises on which this technique is based. What it says is, or before that one, I could have expressed this one even in the mathematical equation form, just like the transportation technique. It is simple as that one. That is what we say: minimize the z is equal to j1 equal to n, I is equal to 1 is equal to n, the Cij xij. Okay, got this one? Cij xij such that sigma j is equal to 1 to n xij equal to 1 for all I is equal to 1 to n. Okay, and similarly xij is equal to 1 for all j is equal to 1 to n. Okay, where all xij's are greater than or they are equal to 0 or they are equal to n. Only two things are possible. If it is allocated, then it will xij will become 1. If it is not allocated, it is going to become 0. That is what it means. Okay, try to compare. This is the mathematical equation and this is the equivalent form of that one. This is what is meant by the mathematical form of the equation which can be written for assignment type of problem. Okay, now we are safe enough to concentrate on the two theorems. Okay. That means one theorem is anything it states that, if you want, you can write it down. In an assignment problem, if we add or subtract a constant to every element of a row or column in the cost matrix, then in the assignment which minimizes the total cost on one matrix also minimizes the total cost on the other matrix. That means what? If I add or subtract a constant to each element. Okay, why we need to do, let us see afterwards. But what we are trying to do is, if I add or subtract any constant to each row and each column for some specific purpose, and if it minimizes the cost, then by doing that one, if it minimizes the cost, then the same assignment would have minimized the cost to the existing matrix. That is what it means. Okay, we'll take up the same example I will take up and then we'll see. For the time being, you try to understand that here we are going to subtract the value, one constant value, maybe any value, one constant. And why it has to be a particular value, the next theorem tells us. Okay, try to understand. Now this is one premises. If we add or subtract any constant to the row and the column of the assignment type of problem, whichever minimizes the value, it also minimizes the value of the other matrix as well. That is what it means. And the second theorem, it states that if allCij's are greater than or equal to 0, that means whatever the value I have given, they are all maybe 0 or maybe greater than 0. No question of negative. Try to understand that. Okay. If they are greater than or equal to 0, and if we can find a set of Xij's such that they are equal to asterisk marks I am going to put Xij equal to Xi, because this is the earlier value whatever I got, and here the change the value whatever I am going to get. In that case, it is such that Cij is the cost, and here this is the earlier equal to afterwards also whatever this is the assigned value. Then if this one cost Cij, Xij, asterisk marks should be equal to 0. I will make Cij values in such a way that this total multiplication of this one, that means j is equal to 1 to n and I is equal to 1 to n, it will become 0. Totally if I multiply. That means what in the essence, what I am trying to do here is, I will try to create, now their Cij's values are so much, I will try to create more number of zeros in Cij's, so that if I go on adding those things, it is going to become 0. Totally it will become 0. Only 0. Which zeros? I am going to create maximum number of zeros over here. So that itself is an assignment. That is what it means. The second theorem, that is why it plays an important role, that it states if I am able to find out in such a way that then whatever the solution I have found out is the optimal solution. When it will become the optimal solution, I need to allocate only zeros. How to create zeros? That the first theorem tells us. How to create zeros. That means it says either you can add or subtract. Here, mostly it is the subtraction. For example, I can create how the zeros, let us see. That is the flood technique itself. This is the two premises on which this one is based. Now the crux is what? Creation of zeros. Now first thing you need to ensure is it should be a square matrix. It should have effectiveness. And always this should be one only. If it is two, no, I cannot solve it. Okay? Try to understand this one. It has to be one only. If there is 2 and it is 1, then I have to resort to some other thing. Either again it needs to be modified. Try to understand this particular thing. So it should be a square matrix wherein the availability is 1 and the requirement is also 1 at each of the destination or source. So now, according to the first this one, in consequence to the second theorem, I will try to create zeros. How best I can create the zeros? In each row and column, that is what we should see. Try to understand, always in this OR technique, we always start with the rows first and then the column. You might have remembered in case of transportation also. First we go for row in northwest corner rule or row minima or whatever it is. We went row by row usually. Usually that is true. Usually, not a general this thing. But here we should start with row first and then column. That is why it is ij, xij, in the sense ith row, jth column. First row, then followed by the column. So there are 4 rows and 4 columns. That is what I have ensured. Now, which is the least amount over here? The least amount, because I need to create 0. For example, if I select some other value, then it becomes problematic. Okay? Say for example, if I select maximum value, 70. From each element, if it is deducted 17 minus 17, it is 0. 14 minus 17, minus 3. It starts creating the problem for me. Okay? That is why what I should do is, I should see that I am going to create the 0, and I am not going to introduce that minus these things. Otherwise, it becomes problematic. That is why what I will do, which value is to be subtracted, which is the least value. Out of these 4, which is the least value? The least value is 13. So if 13 from each element, 13 is subtracted, I am going to get 2 here, 0, 1, 3. Okay? What this one? That means what? 2 into x11, 0 into x12, plus 0 into x13, plus, sorry, x plus x, Cij into x, plus x13, plus this one is x14. If it is allocated, that means 3 into x14. That is what Cij value, 3 into x14 plus 3 into x13 plus 3 into x12 plus 3 into x11 should be equal to 1. Because the availability here is 1. Then where it should be allocated? Wherever 0 is there, because that is my intention. Wherever 0 is there, that is going to minimize the total cost. That is why I am trying to create. So I am going to create the zeros, and I am trying to allocate zeros in such a way that there has to be at least 1 0 in each column and each row. That is what we have to do. Now, each row, first row I have created 1 0. Second row I will take up, which is the minimum value. Minimum value is 11. This is 0, 1, 4, 2. Next I will take up here the third row. Here what is the minimum value? Minimum value is 10. So this is 3, this is 2, this is 0, this is 1. What is the minimum value here? The minimum value here is 14. That means 15 minus 14, 1, 17 minus 14, 3, 14 minus 14, 0, and 16 minus 14, 2. Okay, this is what I have got at the first instance. Now, if we observe here, I should have got 0 in each row and each column. But what has happened? In each row I have got this first row I have got 0, second row, third row, fourth row. But if I go column wise, I have got 0 in first column, 0 in second column, 0 in third column, and no 0 in the fourth column. Then what needs to be done? Because I said basically I should have 0 in each row and column so that the allocations can be made properly. So what is to be done? What we would suggest now? Now we have gone row wise. Now I have to go column wise. That means because the same constant for I am going to apply it to the same column. For different column, different constant, like that. Because I applied different constant to different row, because I had written down the equation. That is what you have seen, is it not? That is what is to be done. It is not going to alter the situation. So if I do like this, here, again I am going to draw this one. There are 4 rows and 4 columns. Now there is a 0, which is because if I go to the first column, which is the least value 0, that means from corresponding element the 0 is to be subtracted, so it remains same 2, 0, 3, 1. If I go to the second column, again it will be 1, 2, 3. Third column if I go, it is 1, 4, 0, 0. Okay, now we'll go to the fourth column. Which is the least value here? The least value is 1. So that means it is going to become 2. This is going to be 1. This is going to be 0. This is going to be 1. Okay, now we can see that we have created 0 in each row as well as each column. Now the assignment may be possible. Then how to make an assignment? That is what is required. That is what needs to be understood. Because by making the assignment, that means which one I am going to consider, whichever is the least, I will consider it. Okay? And whether the optimal solution is reached or not, it should tell us. The one way is, I am going to tell you one way here. We might be fortunate maybe in case of this particular example. Let us see. Now first always I told you I'll go row wise. You try to inspect because I am going to make use of the second theorem now. Okay? The allocation of that means try to understand. Cij x star ij summation. This should be equal to 0. I need to do that means Cij value I want to make 0. This is what? Cij values. That is why I have created that. At least one this thing, because wherever Xij, either it will be 0 or it might be 1. There is no question about it. Okay? Elsewhere it will be, because if I allocate here, Xij elsewhere it is going to be 0. Here also Xij is 0, Xij is 0, Xij is 0. But Cij might be 2, 1, 3. So here Xij is 1 and Cij value itself is 0. That means totally it will become 0, whatever it is. So in each row and each column, the multiplication of that one is going to be 0. That is what value I am able to get that one. How to get, I am going to tell you now. That means you start from the first row, you start scanning till you get exactly 1 0 in the row. Start from the first row. Fortunately, what has happened? There is exactly 1 row in this first row itself. So I will mark this. Since I am going by row wise, try to understand. Since I am going row wise, I will draw the vertical line. It has got particular significance. We will come to know about it. This is the method. What we need to do? First you start with the first row and scan till you get exactly 1 0. Fortunately, I have got here. Since I am going row wise, I have drawn the vertical line. Next, I will go to second row. I will get this one. So again, what I need to do? I have to draw a vertical line. Okay. Next, I will come to third row. There are 2 zeros. What this one? Then I cannot allocate. So I will go to the next row. Next row, because I have to leave because already they have been covered. So this is the thing, I will mark it. I am going, try to understand, I am going row wise. This one, I have to draw the vertical line. Try to understand. Okay. Now, after this one, row is exhausted, so I will change to column. Which is column, these things already they have been drawn, this covered with some line. So only this one, because here also I have to identify that exactly the column which has got only 1 0. And this is the what. So I identify this one. So what is going to happen? I am going by column wise, so I have to draw the horizontal line. Try to understand this particular problem. Okay. Now try to observe. Now you can see that each row and column have got only one zero. And if I follow this procedure, if you follow this procedure, whatever I have done, not only you are able to mark the zero values, and you are going to cover all the zeros with minimum number of lines, which is most important. Because in the textbook it says that you should, if you are able to cover with the minimum number of lines all the zeros, and if these number of lines are equal to order of the matrix, that means here it is 4 by 4 matrix, so if the number of lines are 4, then optimal condition is reached. It will not have more than 4. This is what it ensures. Okay? And if it covers lesser than 4, then the optimality is not reached. Optimal condition is not reached. Have you understood? Now, fortunately, what has happened? I am able to, by using this procedure, I am able to cover all the zeros with minimum number of lines, and this minimum number of lines are exactly equal to the order of matrix, in this case 4. 1, 2, 3, 4. Hence, optimal condition is reached. And let me tell you, it is unique optimal solution. Okay. That means how the assignment is made. That means A1, A2, A3, A4, 1, 2, 3, 4. That means what here? A1 to 1, A2 to 2, A3 to 4th job, and A4 is to be assigned 3rd job. If it is done like this, then it is going to cost 13, A2 to 2, 12, A2 to 1, 11, A3 to 4, 11, and A4 to 3, 14. By intuition also, we might have done like that. I don't say. By intuition, somebody would have got the same answer. This one, this one, this one, and then ultimately this one. Or somebody might have started with this. Then he would have missed this one and this one, like that. So any other thing, any other assignment, it will be more than this. So total value, it works out to be how much? 49. Total cost, if these are the rupees, then at the most it is going to be 49 rupees. It cannot be less, at the least, sorry, not at the most. At least it will cost 49. It cannot be lesser than 49 rupees. It is not possible to complete the job. Or instead of rupees, you can consider it as minutes or hours. So it will take at least 49 minutes or 49 hours. That's the answer. Have you understood this one? So having understood this one, then you need to prepare yourself the flow chart. Because of the paucity of the time, I am unable to give you the flow chart for this one. Okay? Because I have to go further and the time is short for me. But if required, I can repeat it. First, what you do is you need to set it up as the assignment type of problem. When you are going to set it up as the assignment type of problem, when the availability and requirement are 1. And then check for balancing matrix form. That means it should be balanced. Number of rows should be equal to number of columns. That is all. And if some rows are less, number of rows are less, then you add less than the column, then you add one dummy row with corresponding cost or time, whatever is as 0. And if the number of columns are less than rows, then you add one dummy column with corresponding cost or time, whatever it is, 0. Okay? For cost, this one. Okay? And that availability or requirement will become 1. That is how you are going to handle those things, balancing is done. After this balancing, then you check it for minimization. After this one, having done balancing, that is what exactly we followed in case of transportation as well. So then you need to do the check for minimization. If it were minimization, then what we had done? First, all the values of the matrix are to be subtracted from the maximum value of the matrix. Okay, that is how you are going to create the mirror image. So that means now it is a square matrix and it has become the minimization problem. Then you apply this flood technique. That means what you need to go then afterwards, you go on creating 0 in each row and column. Afterwards, then you start allocating. Sometimes it might so happen that you may not be able to cover all the zeros with exactly the order of the matrix. You will have created the zeros, but the number of lines to cover that one may be less than order of the matrix. Then again you need to create additional number of zeros and other things, how it is to be done. So let me take up another example which will tell us how these improvements can be done and how we are going to get the solution. Okay? Because one thing I have taken one simple problem and next one they are under a bit complicated or whatever it is. I can't say that it is complicated. It is also a simple problem. Okay, instead of people, now I am taking jobs and machines. So it doesn't make whether you take job here or job here, machine here or here, it doesn't make difference. Let me say, this one is job J1, J2, J3, J4. This is machine M1, M2, M3, M4. Whatever the values are given here, these are the minutes. Okay. It will just solve the following assignment problem. Okay. 5, 7, 11, 6, 8, 5, 9, 6, 4, 7, 10, 7, 10, 4, 8, 3. So this whatever we have done is, this is assignment type of problem. That is what assignment. Okay. Now here, which job is to be assigned to which machine? And if these are the time taken, such that the total time taken is to be minimized. If so, which job is to be assigned to which machine? That is the question which has been asked over here. So what is the next step now? Next step, I need to create 0 in each row and each column. Okay, let me do that. Okay, J1, M1 I will not write. I will just say which is the minimum here. 5, this is 0, 2, 6, 1. Minimum is 5, 3, 0, 4, 1. Okay, minimum is 4, 0, 3, 6, 3. Minimum is 3 here. So this is 7, 1, 5, 0. You understand? Now I have created 0 in each row. Next I have to create 0 in each column. So this one it remains same because in this column the minimum value is 0, 0, 3, 0, 7. 2, 0, 3, 1. Okay, now 1, 1, 3, 0. Only in third column I don't have 0, so minimum value is 4. So this is going to become 2, this is going to become 0, this is 2, this is 1. Have you understood now? This is what is going to happen. Okay? Okay. Now, having done this one, what is to be done? Next step, we should start allocating the zeros, which will optimize. And simultaneously, we are doing in such a way that to cover all the assignment zeros, mark zeros, with the minimum number of lines, I have given you the procedure. You start with the first row. Fortunately, I am getting single zero here, so I will allocate. I am going row wise. What should I do? I am going row wise, so I am going to draw a vertical line. Next, I go to the second row. Now there are 2 zeros, I'll leave it. Now I'll go to the third row, there are no zeros, I cannot assign. So I'll leave it. Next I'll go to the fourth row, yes, I have got exactly 1 zero, so I will assign, I am going row wise, hence I am going to draw the vertical line. Now row thing is exhausted. Now I'll go by column. This column I don't have. This column is there. There is exactly 1 0 in this column. I'll mark it and I'll draw the vertical line. Got this one? So now what I have done, even though 1, 2, 3, 4, 5 zeros were there, I was able to cover it with only 3 lines. Try to understand. Otherwise, some were there, you would have simply covered it as. Try to understand. 1 line here, 1 line here, 1 line here, 1 line here. So, got sir. What this one? You could have drawn 1 line here, 1 line here, 1 line here, 1 line here. So zeros and all are marked. But the problem is what? You are taken. Then you cannot say that the number of lines are 4 and the optimal condition is reached. No, it is not like that. The marked value should be in each row and column it should satisfy. Because now how many marked values are here? There are only 3 marked values. 1, 2, 3. That means there is no assignment in the third column. There is no assignment, or there is no assignment in third row. Either third column and third row there is no assignment. Hence, what is to be done? To whom it has to be assigned? We don't know. Try to understand. So that is the crux. So in the previous example, we have seen, if I had assigned this one, what would have happened? That we have to see. Okay? Try to understand that. Okay, now assignment is to be made. So what needs to be done next? Next, again, I need to create some more zeros. Try to understand. We are going to create some more zeros. How do I create some more zeros? Now, 2 things or 3 things need to be observed over here. The first thing is, you have seen some of the values have been covered with the lines and some have not been covered. And some of the values or the cost, whatever are there, they are covered with 2 lines, one horizontal and one vertical. Now, first thing what we need to do is, you observe the values which have not been covered by the lines. This is 2, 2, 3, 2, 1, 1. For this one. So, out of this one, which is least, you have to see. Which is least? 2, 3, 2, 1, 1 is the least. So, this 1 is to be subtracted from all the values. Try to understand. That is why second theorem I am going to make use of. Here I am going to subtract. What value? 1. How did I select? This one least. So that means here I am going to get 1 minus 1, 0. 1 minus 1, 0. Then 3 minus 1, 2. 2 minus 1, 1. 2 minus 1, 1. 2 minus 1, 1. This is what I have got. And what is to be done with this one? which have been covered with a single line, you leave them as it is, whatever the value. 0 here, 0 here, 0 here, okay, 0 here, and 7 here. But where there is only crossing, you add that value, whatever we have subtracted. That means I am going to add to this 3, it will become 4, this will become 2, this one was remaining as it is 1, 3, 0. I had not completed this, okay. By doing this one, I have created more number of zeros. Okay, what this one? I have created more number of zeros. Then again try to assign. Okay, first assignment. Okay, I'll get this, draw the horizontal vertical line. I cannot do this one. I'll go this one. I cannot do this. I come to column this one, 2 values. I go to this one, 2 values. Then I'll go to this one. Okay, I'm going column wise. So I will draw this, enclose this one and draw a vertical line. Okay, again I will go row wise, not possible. I will go column wise. Okay, column wise I am going, this one it is done. So I am going to, sorry, column wise I am going now, sorry. So I am going column wise, that means I have to draw a horizontal line. So I am able to assign as well as I am going to draw the minimum number of lines to cover all the zeros. How many lines? 1, 2, 3. All the zeros have been covered. So again, something is not because this first row, first column, there is no problem. The second row, second column, no problem. But fourth row, fourth column and fourth row, no problem. But third row and third column, not assigned. So again, it is to be revised. So optimal solution is not reached. Now again I am going to apply the same thing. Now out of this one, which is the least? Least is 1. Try to observe here. That means whatever the least is 1. So this is 0, this is 0, this is 0, this is 0, this is 4 plus 1, 5, this is 0, this is 0, this is 2, this is 0, this is 7 plus 1, 8, this is 2, that means it will become 1, this is 1, this will become 0, this will be 2, this is 0 and this is 0. This is what has happened. Got this one now? Now I have created, what I did? I created more number of zeros over here. Okay? Now the problem starts. Okay? I'll go for the row, 4 zeros. Then I cannot do any assignment. Next I'll go 2 zeros. I cannot do. I go to this one, 2 zeros, I cannot do. I go to this one, 2 zeros, I cannot do. I go column wise, 2 zeros. One more thing I had forgotten here. There was a 0 here, okay. 3, here 0 zeros, here 2 zeros. What to do then? This itself tells that it doesn't have the unique solution. Now arbitrarily I have to choose. Okay, in whichever way you want to proceed, you need to select it arbitrarily. There's no hard and fast rule. Okay, now I'll select this one. Anything you can select, there is no problem. Okay, that one also we can try it, there is no problem at all. So I'll select arbitrarily. Okay, I'll go row wise, I'll select this, draw the line. Okay, again I'll come to this one. To these things, I'll come to this one, second row, because I cannot choose this one, second row, no, third row, I'll go So this is exactly 1 0. That is why I will select this, and then I'll go to fourth. Here I cannot do this one. I'll come back to this column. No, no. Again I'll select arbitrarily some value and